This is a basic mole-to-mole stoichiometry problem. So the first thing you have to have is a balanced equation. So let's kind of walk through that really quickly. And so where I want to start is I can notice that I'm going to start with my O's here. So I have 3 oxygens on the reactant side, and I have 2 oxygens on the product side. My problem is I can't turn a 3 into a 2 or a 2 into a 3, so I'm going to do a common denominator. So I'm going to get them to equal 6. So I'm going to multiply 2 times 3. So that means this 3 goes in front of the O2. And I'm going to multiply this times 2. And that means a 2 goes in front of the KCl. Well, then I can easily see that my K's have 2 on this side, so 2 times 1. But I only have 1 on this side, on the product side. So I know I have to multiply that by 2. And that will give me 2. And then I'm going to check out my CLs. So I have 2 times 1, so I have 2 CLs. But now I have 2 times 1, I have 2 CLs, so everything matches. So I have 6 O's, 2 K's, 2 CLs, so we're good. So now I have my balanced equation. So the next thing I'm going to look for is my superstar. So to figure out the superstar, I have to why that's blinking. I have to figure out in my problem. So if I look in my problem, I'm going to have 4.25 moles of KCl. And so I'm going to notice that I have 4.25 moles of KCl. So I know that KCl is my superstar. So I have to find the KCl. So up here, the KCl is my superstar. So I'm going to draw a star over the KCl. Well, what does that do for me? Well, I know that everything I've got, so I'm going to write down this 4.25. It says 4.25 moles. I'm going to write down under everybody, but I know who it belongs to. It does not belong to KClO3. It does not belong to O2. This 4.25 moles belongs to KCl, because that's my superstar. It's who the problem is about. But it wants to know everybody else. So I can instantly see the relationships. So I'm going to take the superstar's coefficient, and I know that some proportion of this 4.25 is going to be of KClO3 and of O2. So I'm going to divide out in my fraction this 2. It becomes the coefficient. This coefficient becomes the bottom number in the fraction I'm going to multiply to figure out the amount of the other guy. And then all I do is I put their own number on top. So I'm putting the 2 down here, the 2, and the 3. So then all I have to do is work it out. Well, this makes sense. If I have 4.25 KCl, I should have started with 4.25 moles of KClO3 because they have the same number on top. So they're the same coefficient. I better have the same answer. So 2 over 2 is a 1 times 4.25. So my answer is 4.25 moles of KClO3 is going to be going to have to react to get me 4.25 moles of KCl, which was my superstar given. But then I know I'm going to have more oxygen formed because look at the number. 3 is bigger than 2. So I have 3 halves times the 4.25. So if you work that out, that is 6.38. Now how do I work that out? 4.25 times 3 divided by 2. So that equals 6.38 moles of oxygen. If we look at our questions then, question 1 says how many moles of oxygen are formed if this many moles, 4.25 moles of KCl is also formed. So my answer is 6.38 moles of oxygen. And then question 2 says how many moles of KClO3 must react to form the 4.25 moles of KCl. So I know that that answer is the same because it's a 1-to-1 or a 2-to-2, which is a 1-to-1. So I get 4.25 moles. So this is just the basics for doing a mole-to-mole stoichiometry problem.